Hello, sixth graders. Today we are going to be working on lesson 12.4, which is about algebraic relationships in tables and graphs. I think it should be pages 79 and 80, but it doesn't really matter. Whatever pages you're on is fine. So go ahead and put that in your table of contents. For this lesson, we are going to be using both sides. Instead of having a side for class notes, we're going to use both sides for the lesson. So on the left-hand side, it's kind of hard to see on this, but on the left-hand side, you'll put the title, which is 12.4, Algebraic Relationships in Tables and Graphs. And you'll put a number 1 there. And then on the other side, on the right-hand side, the right page of your math notebook, you'll put a number 2. In box number 1, we're going to talk about writing an equation using a table and a graph. So this is when they give you a table plus a graph with information, and then you have to figure out the equation. And I don't have the graph on here now. Sometimes they will give that to you, but I'm going to show you how to create a graph when they give you the table. Okay, so for Angie, Angie walks at 5 kilometers per hour, and May walks at 4 kilometers per hour. And I accidentally put this underneath the graph. You may want to move it up above the table, just so that you have that information at the top. So we know Angie walks at 5 kilometers per hour, and May walks at 4 kilometers per hour. Then they gave us a table for Angie, and we have a table for May. So go ahead and draw those tables with time and then their distance. So for Angie on the left, it will be time in hours and her distance in kilometers. And her time in hours will be 0, 1, 2, 3, and 4 hours. And for May, it will be in hours 0, 1, 2, 3, 4 for hours. Then on the left, for Angie's distance, you can see they started the table. We're going to finish it out. I'm going to zoom in a little bit to make it bigger. Okay, so Angie goes, in 1 hour, she goes 5 kilometers. In 2 hours, she goes 10 kilometers. So in 3 hours, she's going to go 15 kilometers. So fit that in there. And in 4 hours, she's going to go 20 kilometers, if we follow that pattern. For May, she only goes 4 kilometers per hour, so she's just a little bit slower than Angie. So for 1 hour, so they go, for 0 hours, they go 0 kilometers. For 1 hour, 4 kilometers, 2 hours, 8 kilometers, 3 hours would be 12 kilometers, and 4 hours would be 16 kilometers. I know that's hard to see. Let me see if I can zoom out a little bit and maybe fix that. I don't think it's going to let me. Okay, so just know that this is 16 under the 4. Okay. All right. Now, like I said, I think in the book they actually give you the graph, but I'm just going to show you anyway how to make a graph using the table. So for Angie, we're going to make a graph for Angie, and we have her time in hours. Okay, and that's, so we're going to put those time in hours on the x-axis, and that will be 0, 1, 2, 3, and 4. That's how many hours she goes. And then on the y-axis, we're going to look at the table, and I can see that she increases by 5 for each hour. And so we're going to use intervals of 5 because it goes 5, 10, 15, 20. So those are good intervals to use for my graph as well. If I'm making my graph, I can make it nice and neat like that. Sometimes they don't give you a graph that's that easy to read. And then, you would draw the grid lines if you didn't have a graph. And I apologize that my lines are not that straight. Do the best you can, use a ruler, or just be really careful. And then you would just graph those ordered pairs, and remember, time is going to be x and distance is going to be y. So for 0 hours, she goes 0 miles. For 1 hour, she goes, not miles, kilometers. For 1 hour, she goes 5 kilometers. 2 hours, she goes 10 kilometers. 3 hours, she goes 15 kilometers. 4 hours, she goes 20 kilometers. And then for May, again, I'm going to do the x-axis first. And for time is again 1, 2, 3, and 4. And then my y-axis, this time since she goes a little slower, her distance goes up by 4 each time. So I'm going to use intervals of 4. So 4, 8, 12, 16. And then I'll draw my lines the best that I can. Okay, and then I'm going to graph those on. So in 0 hours, she goes 0 kilometers. 1 hour, she goes 4 kilometers. 2 hours, 8 kilometers. 3 hours, 12 kilometers. And 4 hours, 16 kilometers. And I know these are kind of easy, but they teach you the concept, so they start out a little bit easier. And then you can use a line to connect those. Draw a line to connect those from 0 out. And that could help you predict future answers as well. So to write an equation, and I'm going to zoom back out again a little bit so you can see. To write an equation, I look and I say, oh, I can either use the table or the graph, and I can say Angie's distance goes up by 5 for every hour. So she has multiples of 5. So I'm going to write the equation as a relationship as y as it relates to x. So I'm going to say y, which means on my y-axis, is going to equal 5 times whatever x is. 5 times her hours. So 5 kilometers per hour. So y equals 5x. For May, hers is going to be y equals 4x because for every hour she walks, she goes 4 kilometers. So her equation is y equals 4x. Okay, and on the next page for number 2, we're going to write an equation from a graph. So they're going to give us a graph, and we're going to figure out what the equation will be. And I left some words out, so I'm going to have to add them in. So bear with me for just a few minutes. So it should read, Charisse pays the entrance fee to visit a museum, then buys souvenirs at the gift shop. The graph shows the relationship between the amount spent at the gift shop and the total amount spent at the museum. So I'm sorry that's such a mess, but go ahead and fix that to read correctly. Then they give us a graph, and we have an x-axis and a y-axis. X is going to be the how much is spent at the gift shop. Y will be the total amount spent. So if she spends $0 at the gift shop, she spends a total amount of $5 according to this graph, because gift shop is X, total amount is Y. So if, and I'm going to enlarge this a little so you can see it a little better. If $0 is spent at the gift shop, she has a total of $5. So that would be 0, 5. That would be the ordered pair. 0 for X and 5 for Y. If she spends $5 at the gift shop, then her total cost will be $10. If she spends $10 at the gift shop, her total expense is $15. If she spends $15 at the gift shop, she spends a total of $20. If she spends $20, she spends a total of $25. And I'm going to see if I can zoom that in a little bit so you can see it better. This should be 15. And this last box should be 20 at the top, and then underneath it should be 20 and 25. Okay, so then those are my ordered pairs. 0, 5, 5, 10, 10, 15, 15, 20, 20, 25. I don't need the next one. I could keep going, but that's all they have on the graph. So I'm going to look at the pattern in the table. And basically, for you have to add $5 for the entrance fee to whatever she spends at the gift shop to get your total. And so the total amount, we're going to say the total amount equals $5 more than the gift shop amount. And I know that's really hard to read. I apologize. There's so much writing in this one. So that you should say the total amount equals $5 more than the gift shop amount. Because she spends whatever she spends at the gift shop plus the 5 to get into the museum. So to write an expression, it says write an expression that expresses the total amount spent Y, which is Y, in terms of the amount spent at the gift shop, which is X. So Y is going to be her total amount, and it's going to be whatever she spends at the gift shop, which is X, plus her entrance fee of $5. And that is the equation. And that's how you do it. And we'll do some more practice in class, but hopefully that makes some sense to you. And if not, hopefully we can clear it up in class. And that's it. Good job. Except I forgot to show you the last page, so let me show you the last page. I mean the final page. Okay, the last part should be what your page should look like basically on the left, and then the next slide, or the next one will be what it looks like on the right. So on the left, you should have had Angie's equation equals y equals 5x, and May's would be y equals 4x. I forgot to put this in. And on page 2, this is what your second page should look like with the corrections made here. Again, because I goofed that up. So I'll just fix that. And then you'll be done. And we can look it over in class too, and you can fix it if it's confusing to you. Okay, that's it. Good job.